Alright, so as promised, we have here another 3 sets. That would be sets A, B, C. And we'll try to classify these sets according to type with respect to WOP or the principle of well ordering. So let's start with item number 1. That would be set A. As noted in my previous video, for us to classify the given set, if that set would be of type A, B, or C, try to list elements of that set, and from that you can now classify what type that set is. Could it be of type A, meaning if that is empty or that contains the least element, or will just be arbitrarily or infinitely small integers. So as for set A, it says that we are to have elements which are integers, and that integer should be greater than 7. Clearly, that set would start with 8, and since we're having here integers, the next would be 9, 10, 11, and until to positive infinity. The roster method or listing method would start with 8, next would be 9, 10, and so on. There. So now that we're able to list elements of set A, definitely it's not of type A here, because of course set A here is not empty. Since we have a least element and that least element is 8, hence set A is of type B. So I hope by now you notice that if a given set is not empty, then you just have to check if that set has a least element or it doesn't have one. So if it has a least element, automatically that would be type B. If not, and if that set is not empty, then automatically that contains arbitrarily small integers or infinitely small integers. So let's proceed now to item number 2, and that would be set B. Set B here will have still, of course, set of integers. Our elements here are integers, considering of course that WOP would only work for and would only be valid for a set of integers. We have here predicate that RB here should be greater than 3/5 but less than 2/3. So again, let's try to list, if we can, let's try to list elements of this set. Can you think of an integer that will satisfy this predicate here? An integer which is greater than 3/5, or that's 0.6, greater than an integer greater than 3/5 but less than around 0.666, and so on. Do we have one? Clearly, we cannot look for an integer which is greater than 0.6 but less than 0.66666, and so on. We can pick a number if we are to consider real number or rational number, but considering that we can only have an integer, then we cannot list, in this case, an integer that will satisfy this predicate. So in that case, set B, or the set in item 2, would be of type A. How about item number 3 this time? Set C. So we have here, so let's try to list elements of set C, wherein this integer would satisfy this equation here, C is equal to 2x, where x is an integer. So we'll try to list the elements here. If x is equal to -1, clearly C would be equal to -2. If x would be -2, our C here would be -4. set C is actually the set of even integers. Since set C would be the set of even integer, we'll have here this. Clearly, it's not empty. This would not be of type A. Could we look for a least element? No, because whenever we'll try to pick an element in this set, we always have a number smaller than that. Therefore, this set C would also be of type C because it contains arbitrarily small integers or infinitely small integers. Alright, so just in case this another 3 sets would still not be clear for you guys as we're trying to discuss principle of well ordering, feel free to comment or inform me that you want to have another set of examples for WOP. Alright, so just in case as well that you're ready now to watch my next video, which would be about principle of mathematical induction, then just click the next video right here, right? And don't forget to subscribe so that you'll be updated with my next videos. All right, thank you.